So here's a little bit of naming here. This is called just a number. Believe it or not, a number is a polynomial. It's a special case of a poly means many terms, but even a single term is still considered a polynomial. So believe it or not, all these numbers you've been working with all your math career have been polynomials. So standard form.
They're undercover.
They're undercover, yes. So standard form for the number 12 would still be 12. Standard form for this, 8 plus 7x, would be 7x plus 8. Please write this down, guys. What we do is we write the highest power term first, and then we go down in descending order of powers from there. Okay, I'll show you what I mean in the next one. Y squared would be written first, and then 2y, and then minus 4. That's standard form for that polynomial. You can write this down. Okay. Chapter 8, section 1. Find the table. This last one, which term is going to go, or second to last one, which term will go first here? Yeah, it's already kind of in standard form, at least the first two terms. But then we've got to change the order, move the x up, and then minus 1. So that thing's got 4 terms in it, and it goes from x cubed to x squared to x to the constant. And then the last one on here, even though it has a negative in front of it, you just bring the negative with it. It's negative 9x to the 4th plus 6x squared plus 7. But that's how we write these polynomials. Every one of these is a polynomial in standard form. It's got to be the highest power term comes first, and then it descends from there. And the reason we do that is so that we can quickly and easily tell what the degree is. You can just look at the first term, and the degree is decided by the power on the variable. Now that may pose a problem because 12 does not have a variable attached. But let me ask you this. If I were to attach an x to it, what would the power have to be on it? Good guess?
0.
But, okay, better. That's it. That's actually correct. So why 0? I don't know. If I were to attach a variable to a constant term, to just a number like 12, it would have to have an x with the power of 0 on it, because anything to the 0 we know is equal to 1. And so this is just 12 times 1, or 12, right? So it doesn't change the value of it. So we call that degree 0. And then we're going to work our way down here. What's the unwritten power on the x? This one. It's 1. It's incognito. So the degree would be 1. And then this one right here, it gets a little more obvious once you get to second degree and higher. But this would be of degree 2. And this one would be of degree 3. And then of degree 4. And the name from degree, we just call it 0 degree, or we actually have a special name for this. It's called the constant, because there is no variable, so it cannot change depending on the number that you plug in. So we call it a constant because it stays 12 all the time. This one we would call first degree, and then second degree, and then third degree, and then fourth degree. So by degree, we can name it by degree. We can also name it by number of terms. This first one, the constant, has only 1 term. The next one has 2 terms. The next one, 3 terms, 1, 2, 3. Terms, once again, are separated by plus and minus signs. This one is 4 terms, then we're back to 3 terms again here. Now, we have special names for the first 3. For 1 term, 2 terms, and 3 terms, they're special names because they show up so often. A 1-term polynomial is called a monomial. It's a monomial. They used to have skis called a monoski. They're the precursor to the snowboard. You just step in and you're face forward. It's like a snowboard facing forward. That is a monoski. Back in the 80s. Monomial. So mono is 1. 2 terms is binomial, like a bicycle. Binomials are like riding a bike. It's the monomials that are hard. And then trinomial is 3 terms. This would also be a trinomial down here. And then when we get to 4 terms or more, we just call it a polynomial. So 4, 5, 6 terms, just call it a polynomial. That's it. So that's one thing I'm going to ask you to do is be able to name these by degree or by number of terms. All right. Now, on this example, I want to show you how to handle something that has more than one letter in it. We'll get to that in a minute. But this one would be what degree? Just based on our chart. First degree. This one would be 7th degree. What do we call this guy? Just the number 4. Constant, yeah. I guess you could call it 0th degree, but if you just say constant, that would be perfect. Constant or 0 degree. 0th degree, I guess. It's kind of weird to call it 0th degree, but usually we just call it the constant term. Now, here's what you do when you have a term with more than one letter in it. You add all powers. And so this is actually 5th degree. It is 5th degree because you add the powers, the 2 and the 3. So could you do, what would the degree of this one be here, the 8xy? Good guess, you're close. They both have a 1 on them though.
Oh, so it's B second.
Yeah, it's 2nd. And then this one right here, got a 4 on the y and a 1 on the z.
Okay.
5th, yeah. So that's just kind of like the added note to self is when you have a term, a monomial term, or even a polynomial term, you look at the whatever term has the largest sum of the exponents on the different variables would be your degree. We're not going to work with too many polynomials that aren't in one variable. So then you have your constant term there in your first degree. So you're going to be asked to classify polynomials. It says write each polynomial in standard form. So how do I change 3x plus 4x squared to standard form? What do I have to do to change that to standard form? Flip them around. Yep. So 4x squared goes first. Plus 3x. What's the degree? Name by degree?
3.
Well, we don't add this time because you only would add the powers on the different variables for one of the terms. So we look at the leading term, and that's the degree. So it's 2nd degree. And then the name by terms, we got monomial, binomial, trinomial. This is binomial. All right. And this guy right here, let's put it in order. 5x cubed first. Look what happens. Look what happens here. These are like terms. You guys know what like terms are?
Combine.
Okay, we do combine them. Like terms mean they have the same variable to the same power attached. So a like term, 4x and 7x are examples of like terms. You would add the 4 and the 7 to get 11x and then minus 1. So this one ends up being a 3rd degree trinomial once you combine the like terms. So 3rd degree trinomial. Try the ones down here. Let's see if it matches what I get here. Try it on your own and see. Look up and check. So in that second one, once you combine the like terms, it ends up being only a binomial, not a polynomial. Well, it is a polynomial, but not a by name polynomial. questions on that so far. So can we write it in standard form? Decide on the degree and name it based on the number of terms. Right, so we're going to work on just adding and then also subtracting these polynomials, whatever size they are. Monomials, binomials, trinomials, or larger. So adding or subtracting them. It really connects to what you may have heard called combining like terms. So if you understand what like terms are, just remind you of what like terms are here in this example. 3x squared and 5x squared are like terms because they both have an x squared attached. So the way we handle this is we take the 3 and the 5 and we add them together to get 8 and then attach the x squared. Some students want to write that as x to the 4th. We do not add the powers on the variables because we're not multiplying them as our rules of exponents say from last chapter. We are adding two like terms. So it's just like adding 3 and 5 and then attaching whatever the label is to it. You're adding two things that are similar and telling how many total x squareds do we have. We have 8 x squareds, right? So you're labeling 3x squareds, 5x squareds. If I were to draw x squareds, there's 3x squareds right there. And then that 1, 2, 3, 4, 5x squareds right there. So I have 8 total x squareds. Or literally 8 total squares. And then up here, I don't really know how to draw an x squared y, but if you were to draw an x squared y, whatever it looks like, we have how many of them? 4 of them here and 1 of them here. So a total of 5x cubed y's. So 5x cubed y's. Now, here I have a trinomial plus a trinomial. It works the same as what I just did above, but you take it piece by piece. So the first thing I'm going to do is just look at the x squareds here. How many x squareds do I have?
1.
Well, I have 1 here and 1 here. One of them, it says there's 4 x squareds. The other one says there are 2 x squareds. How many total x squareds would I have? 6 of them, right? So if you picture x squareds as like what I drew up here, there are 6 x squareds. They actually have these little things called algebra tiles. I don't know if you ever worked with them, but the x squareds are literally squares. They have usually a different color than the x's. The x's are usually long, skinny things that look like this. Did you guys ever use these? And then the constants are little itty-bitty squares that look like that. And so you get the idea of like terms based on the picture. So if I were to draw 6 x's, they would look like this. There's 3, 4, 5, 6 x's. And then I would draw another 9 x's, but they would maybe be in a different color because they're negative. And then they would cancel each other out, and you'd end up with a certain number of different colored x's. I'm sorry, so you guys have any of you seen these algebra tiles at all? Drawn them? I know sometimes they'll draw squares as x squared. They'll use lines. So as you can see, I'm struggling to draw the little rectangles here. So sometimes they'll use lines for these. And then the negative ones, they might cancel them out or something. And then they'll use, like, instead of squares, they'll just use little dots because they're quicker and easier to draw. But we may reference those. I don't think we need to here. How many x's do I have? If I have 6 x's here and negative 9 x's here, it's going to be negative 3 x's. So hopefully you don't have to draw pictures of it. So you can just do the 6 minus 9 and be good to go. But like as you're building up like a 5th, 6th, 7th, 8th grade, they do that now. So 7 plus 1 would be 8. So that's combining like terms. I think some students will also do what I'm doing here is like identify the different like terms with symbols, either circling, underlining, squiggly line underneath, or just so you don't miss any terms. That's a method you could use. I have some students that like to take the two polynomials, like let's take this one down here and write them vertically. like this. And then x squared minus 6x plus 5. Put a line underneath it, plus sign over here, lining up all the like terms. And so this one would be, how many x squareds do I have? 8x squared. And then here, negative 2x, and then 8. So some students like to do that. In your classwork, you'll see it arranged that way, so arranged vertically. You know, how would that work for something like this? Well, you'd have to rewrite the second one. So you have 3y cubed plus 5y, let's put it in order here, plus 7y squared plus 5y. So you'd write the first one in standard form, and then right underneath it, you'd have to rearrange these terms to line them up. So you'd have negative 6y to the third plus 2y to the second plus 7y. And then I have this minus 9 kind of hanging out over here. It's not going to get added to anything from the first polynomial, but that's okay. We just bring it down. It's like adding it to a 0. So how many y cubed terms would I have? Let's do 3 minus 6. 7 plus 2 is 9y squared. 5 plus 7 is 12y. Bring down the negative 9, and there you have it. So you can do it either horizontally or vertically, whatever works for you, where you like to do that. Now when it comes to a monomial term, just adding this monomial term to that, you just negative 6 plus 11 is 5x to the fourth. Or this one is 9x to the second y to the fourth. The like terms are the x to the second y to the fourth terms. Primarily we'll be doing stuff like this. Lots of quadratic trinomials, because that's primarily what we deal with. In second semester Algebra 1, we do a lot of working with trinomials. We're going to learn to factor trinomials. We're going to learn to add and subtract trinomials, primarily binomials a little bit too. So subtracting, let's see what subtracting looks like. Same idea, it's just like adding a negative, but 4 minus 1 would be 3, x to the third y. And here if I subtract, there's a couple different ways to do this. Some students will treat this like the distributive property, like there's a little unwritten negative 1 right in front of the parentheses, and so they just rewrite the whole problem and turn it into an addition problem. Notice I'm dropping the parentheses. I don't need to have the parentheses on the first polynomial. There's nothing out in front of it to distribute. The second polynomial, see this negative sign right here? You see it? Negative sign in front? It's going to change all the signs for everything that follows it. So it's minus 7m to the third plus 9m minus 6. So I'm distributing this minus sign to each of these three terms, here, here, and here. And so you'll notice they have the opposite signs here. And so now it's just like what I just went over. It's just, if you were just thinking of it as adding. So I identify my m to the fourth term. There's only one. There's nothing to add it to. So I have 2m to the fourth. Then I identify my m squared terms. Here's one right here. And that's it. So I just write down, oh, I don't want to write that one down yet though, because see how I have an m to the third term over here? I want to write that down first. So minus 7m to the third plus 5m squared. It's not until I get to the m terms that I actually have like terms. I have a negative, hopefully you can see this negative sign here in front of the 8. Negative 8m plus 9m is 1m. And then finally, I need another symbol. I've used rectangle, circle, straight line, squiggly line. I don't know. How about that? Negative 7 and negative 6 is negative 13. And so you can turn subtraction into addition of negative numbers, or of the opposites, okay, in that way. So first thing I did was to distribute or multiply this unwritten negative 1 by each of the three terms in this polynomial, and then added or combined like terms. The other thing you can do is write it vertically. So take this one down here, 6c to the third minus 7c squared plus 10c minus 4. If I want to subtract from it 2c squared, I'm going to make sure I write that underneath the 7c squared. So 2c squared plus 9c minus 8. I'm going to just write it vertically. I'm writing it vertically here. Lining up all the like terms, and I'm leaving the parentheses around what I'm subtracting. That's to remind me to subtract each term. Don't keep going back to the minus sign. So that's 6c cubed minus nothing is going to be 6c cubed. And then I have negative 7c squared minus 2c squared is negative 9c squared. Let's back up again here. I'm taking negative 7 minus 2. Okay? So that's how I get the negative 9. And then I have 10c minus 9c is just 1c. And then I have negative 4 minus negative 8, which is the same as adding 8. Negative 4 minus a negative 8 would be adding 8. So that is positive 4. So some students like to write it vertically like this, and others like to do the distribute and then just turn it into combining like terms or adding. It's your choice. So you could write a little summary on that. Summary of something that stood out to you from this. Maybe something you didn't know before.